Alright, Hosses, welcome back, and now that we got all the boring stuff out of the way, let's go ahead and get to the good stuff, actually inverting that image. So the first thing I want to do is just add a comment, and I will say, like, invert a bitmap image. Alright, so we named it invert image, and it's going to be public static, and also it's going to return bitmap data invert image. Now, remember, what we're going to be doing is we're going to be passing in essentially my profile picture after it's converted to a bitmap, and it's going to build an entirely new image based on that, and it's going to return that new image. So that's why we return bitmap right there. And also for the parameter that it accepts is going to be a bitmap image, and I'll just name the original image original. Why not? So again, the first thing we need is pretty much a blank bitmap image, and this is eventually going to store the cool new inverted image. So bitmap, I'll just name it final image. And in order to create pretty much a blank canvas that you can create a new bitmap on, you set it equal to bitmap dot create bitmap, and the parameters that this takes is, first of all, you're creating a new bitmap, you need to tell me how big it's going to be, how wide and how tall. So we're just going to say, well, actually go to the original image and get the width of that, and also get the height of that. So the new image that we're creating is essentially going to be the same size as the original. Now the last parameter that this takes is just one that's original, called getConfig, and this is just background information. Because this create bitmap, it takes 3 parameters, and this is the third one. But later on, again, this is just a blank image right now. Just think of it like is a white square that's 230 by 230, and we're going to be building the new image directly on it. So how this program is going to work is this: we essentially have that blank white square that we just created in memory, and we have this original image. So what we want to do is we want to loop through every single row and every single column and look at the pixels one by one. Now every single pixel we look at, we're just going to be inverting, in other words, tweaking the value a little bit and sticking it on this new image. So we're going to be building this new bitmap piece by piece, pixel by pixel. So the first thing that I always say the first thing. It's like, this is the second tutorial and I've done like 70 different things, but it's always the first thing. It's kind of weird, but you know, hey, life is funny sometimes. Alright, so we need variables to store that information. So every pixel, as you know, it's made up of RGB, a red, a green, and a blue value, but we also need the alpha value, in other words, the transparency. So we're just going to be storing them in variables A, RGB, alpha, red, green, and blue, and also the individual pixel. We're going to look at a variable called pixel color. This is just to store one value. So, like I said, we're going to be making a for loop. Where's my image? We're going to be making a for loop that loops through every single pixel, and in order to make this, you actually make a for loop within a for loop, so you can loop through the columns and the rows. So how many times does your for loop have to loop? Well, it depends on how big your image is. So if you make a variable called height, then we can just copy this right here. So for this image, since it's 230 by 230, it's going to say, okay, get height, which pretty much means how many pixels tall, and we're going to be storing it in that. And for this, of course, we already know that the width is right there. And this is just so we don't have to hard code the values 230 by 230, because if we ever throw an image in here that is a different size, then I want this program to be compatible with that as well. So now to loop through every pixel, int y equals 0, y is less than height, and y plus plus And inside here, just going to be copying all this. And my counter variable is x. And of course, instead of height, we want width. So again, a loop within a loop. And all that's just going to do is be responsible for looping through every single pixel. Obviously, simple stuff. So now what I want to do is I want to grab the first, well, a single pixel. Whatever pixel you are currently on, just grab that pixel. So if I go to pixel color, then what I can do is I can go to the original dot get pixel, and in here I can just pass in x and y. So again, the very first value of this, the very first pixel it's going to look at is 0, 0, the pixel in the very top left corner. So we are essentially looking at that pixel and storing it in a variable called pixel color. So now what we need to do is we need to break up that pixel into the individual values. So what we need to do is we need to set this equal to color dot alpha pixel color. So pretty much get the alpha value of this pixel. You know, it may be easier if I just explain it this way. So let's first get the individual information about each pixel. So red, and do this for each one. So this is just going to return how much red is in that individual pixel and store it in the variable red. And now I'm going to do this with all my other colors. Oh, no, no, no. And B. Alright, so this gets the green value of that pixel, and this gets the blue value of that pixel. Now, what we can do is, right now, all of these values are just the same as the original. However, we want to tweak them. We want to invert them. Now, for the alpha, that can stay the same because we aren't really worried about it from this tutorial. However, to get the inverse of it, the RGB, what we can do is take 255 and subtract the red value of the original photo. And we can actually do this for everyone. So paste it in here, paste it in here. So now I have new values for A, R, G, and B. The alpha is actually the same, but the R, G, and B is 255 minus the red value of the original, minus the green value, and the blue. So now what we can do is take these new values for every single channel and build that final image, that image that we were hoping to return. So for the final image, what we can do is actually we can call something called set pixels, and if we type X, I'll explain what this does in just a second. Color alpha, red, green, and blue, A. Alright, that was a nice burp, by the way. Alright, and why is this giving me an error? It is because I set pixels instead of pixels. Alright, so again, what we're doing is we're looping through pixel by pixel, and then we're taking all of the pixel information about that pixel, all of the values, and we are inverting them. And then we're saying, okay, for the final image, for that new image that you're building, take whatever pixel at this appropriate coordinate and set it equal to the new values. So again, pixel by pixel, row by row, we're going to convert this into a new inverted image. And that's it. The only thing we have to do now is return this. So let me make sure I put it in the right place. So return final image. So when this is done looping, you're going to have a brand new image. So now if I run this, all right, there, wow, this is creepier than I thought it would be, but that is how you invert an image. And in the next tutorial, it's not going to be as creepy. You know, I'm just going to get rid of that right now. I don't want to look at that anymore. But in the next tutorial, what I'm going to show you guys how to do is use this filter and overlay on this image, so it'll be a lot less weird and scary. So yeah, I'll see you guys then.